Ladies and gentlemen, welcome to the Geological Society of London and to this, the fourth Society London lecture for 2014, entitled Fracked or Fiction? So what are the risks associated with shale gas exploitation? My name is David Shilston and I'm president of the Society. It's my pleasure to introduce today's speaker, Professor Richard Davies of Durham University. Shale gas has, of course, been the subject of considerable political and public interest over the last couple of years, both in the UK and more widely. In the US, it has been credited with transforming the energy market. It has long been known that natural gas occurs in shale rocks, but it's only recently become possible to extract this gas economically through the combined use of hydraulic fracturing or fracking and horizontal drilling. Each of these technologies is well established in its own right in the oil industry, where they have been used to extract conventional oil and gas reserves. But their use in combination, sometimes in areas where there is little history of conventional hydrocarbon extraction, is new and unfamiliar to the public, who understandably have questions about whether these technologies are safe. The public and environmentalists have raised a variety of questions, from the impact of the extraction and use of shale gas might have on global carbon emissions, to more local environmental and safety concerns. Our speaker this evening will address three of the questions which have most concerned local communities where shale gas operations have taken place or are planned. One, can the process of fracking itself lead to water contamination? Secondly, can it cause earthquakes? And three, could methane leak from the wells that are drilled? Richard Davies is Professor of Energy at Durham University. Richard spent 8 years in the oil and gas industry in the UK and USA before becoming an academic. And from 2009 to 2013, he was director of the Durham Energy Institute. And he is now Dean of Knowledge Exchange and Impact. Richard has over 80 research papers to his name, and since 2011 has focused his research on providing independent evidence on the environmental risks of shale gas and oil exploitation. He now leads an innovative research consortium called REFINE, Researching Fracking in Europe, which shares this vital aim of providing independent scientific evidence to inform decision-making about shale gas. Ladies and gentlemen, please welcome Professor Richard Davies.
Thank you very much for that introduction. And just to clarify, Professor of Energy, not engineering. So my background is in geoscience, actually. I worked in ExxonMobil for about 8 years in the UK, drilling deep water wells west of Shetlands with engineers. And I also worked in London and Aberdeen and in Houston. And then I resigned from the oil industry about 10 years ago. So I've been an academic for 10 years. In 2006, I started researching a mud volcano that erupted in Indonesia called the Lusi mud volcano that David knows well. It caused 40,000 people to lose their homes. And there was a big debate about what caused that volcano. It erupted mud and water onto people's land and into their houses. And the debate was it caused by an earthquake or was it caused by drilling? And the research we did at Durham, along with other people from around the world, proposed it was caused by drilling. It was a blowout, a very unusual type of blowout. So since then, I've been interested in doing research that's relevant to people, particularly when there's a gap, when there isn't enough information. And over the last 2 years, I've traveled around Eastern Europe, Ukraine, Bulgaria, Romania, Lithuania, Poland, you name it. I've been to all of these countries, talking to everyone from the local mayor to the local NGO to politicians about shale gas and oil. And every time there was a question asked, I couldn't answer. I wrote it down. I came to talk to colleagues. I talked to industry. Do you know the answer to this question? No, we don't. And that's what I thought would make a very good research consortium, to take the questions that members of the public have set and go about researching them in an independent and neutral way. And that's what the REFINE project is doing, researching fracking in Europe. Okay, and I'm not sure what sort of audience is here. Let me just do a quick straw poll. Any geologists in the room? And I know there are some. Wow. Okay, so the oil industry is in the room, and people who perhaps work in universities and other sectors. Any engineers, engineering background? Handful, okay. Very interesting. So this afternoon it was a completely different group, and so a lot of this, I'm trying to pitch my talk a little bit. Some of this you'll be familiar with, some of it will be new, and I apologise if it's one or the other. But shale is actually quite a common rock. We have it in the UK. We know we've got Carboniferous shales, and there's also Jurassic shales. And many parts of the world have got shale rocks, and they were deposited often tens of millions of years ago. And in the sediment is organic matter. And that organic matter produces gas or oil as the rocks are buried to 1, 2, and 3 kilometers and beyond. But the gas and oil that's produced sometimes can't escape from the shale rock. This is some shale from Edale. Some of the people in the room have actually been here because I've been on field trips with them to these locations. Some of the gas and oil doesn't escape from the shale. It's kept there and can only be liberated by dramatically increasing what is called the permeability. So think of a sponge that you have in the bathroom. It's got lots of holes in it, allowing fluids to flow through the sponge. But shale's different. There are pores, but they're very small. And gas and oil that's produced in the shale can't necessarily escape. Now, what George Mitchell found in the early 1990s was that he and his company could start to make money by combining fracking technology with horizontal drilling, multi-stage fracking with horizontal drilling. And that technology allowed the company to start to produce gas from shale successions. And that was where the shale revolution started. So just to recap, for the people who are not geoscientists in the room, this is a schematic you've probably seen, many of you, several times. Over here is a conventional oil field or gas field. It's trapped beneath a geological structure, in this case, a fold. And the well has been drilled into that structure to produce the gas and oil. And because the reservoir is a bit like a sponge, it has pores within it, the gas and oil can move through the rock and up into the well. Now, in drilling for these sorts of structures, people have also drilled through shales in order to find conventional hydrocarbons. And as they've drilled through the shale, occasionally there's been a little bit of gas coming into the well, indicating the gas actually flows. The shale flows gas or oil if it's given enough time. So what is now being done is vertical wells are being drilled into shales and then deviated so that they are horizontal, and multi-stage fracturing is carried out. So in this schematic, and I want to emphasize one point about this diagram, which is the scale bar, we're talking about reservoirs that are usually 2 or 3 kilometers underground. There's a vertical well, and the vertical well is deviated and landed into shale layers and drilled horizontally, perhaps several hundred meters, perhaps a couple of kilometers. And in fact, the UK was very important for developing horizontal drilling technology. Wych Farm on the south coast of England had the world's record for drilling a horizontal well for a number of years. So the horizontal wells people have been doing for some time, and then they've been fractured many times. So the fracturing starts at the end of the borehole, and then there's a number of fracturing stages until you get to the heel of the borehole. So perhaps there'll be a dozen fracturing stages. The fracking technology had been around the oil industry for many decades, but it was the combination of fracking multiple times and horizontal wells which yielded fast enough rates of gas flow to produce a rate of return for George Mitchell in the early 1990s, and off went the shale gas industry. So if we look at just one small part of this diagram, just this little white box here, what's actually happening is that industry is generally using water with a small percentage of chemicals and also proppant, perhaps grains of sand. And the way the fracturing is carried out by pumping this fluid down the borehole and to such a high pressure that it's strong enough to crack the rock. And to do that, you've got to overcome the tensile strength of the rock, you've got to break it, and you've got to push it apart. So you need significant forces to do that. And they want the cracks to be dense and not one big crack to form, but lots of small cracks to form in order to stimulate the reservoir. Now, your little molecule of methane that's been sitting there in the shale for tens of millions of years now has a route, a sort of motorway system, if you like, that allows it to come to the surface. So the fracking fluid is pumped into the well during multiple fracking stages and then flows back to the surface. And then the gas comes up with that flowback fluid. Eventually, the flowback fluid stops being produced, and you've got a flow of gas or oil from the fractured reservoir. The sand grains, or the proppant, whatever the proppant is, goes into the cracks and then holds them open, providing a permeable route for the oil or gas to flow through. The flowback water comes to the surface and, of course, is contaminated with some of the chemicals which were put in the flowback water, in the fracking fluid originally, and, of course, natural contaminants from the rock layers. Shales are naturally higher in radioactivity than sands, so you get a level of naturally occurring radioactive material in the water that comes back. So, shales are often highly saline, so the fluid you get back could be highly saline. Okay, so those are the principles of how fracking is done. Just to remind you, standard vertical and horizontal well, just like many wells have been drilled before. The wells are drilled and cemented and protected with steel casing. The well is then fractured multiple times along a horizontal section, particularly if it's a production well. If it's an exploration well, it may be just a vertical well that's carried out. And the fluid is a fluid water with chemicals added in order to get the optimum fracking operation, and then we get flowback water that brings the fluid back up to the surface. What I said to the audience in the afternoon, and I say it to everyone, is sort of think of this room as the geology. The lights at the top are where the well is being drilled from. The shale layer may be the platform I'm standing on, okay? And the aquifers are just underneath the surface, perhaps where that big projector is. It's just underneath the surface. And there's a big separation on the whole between the aquifers and the reservoir down here beneath my feet. That's the sort of scale that people are talking about. In exploration, and many people who have worked in industry, if you've worked in industry or other sectors, you'll know this already. But the progress that has to be made to go from geology and seismic data through to an exploration well, through to development, production, and then abandonment, has many different stages to it. And it's quite possible that after an exploration well has been drilled, the rocks aren't suitable for fracking. If they have too much clay in them, there's a suspicion that they won't be brittle enough to fracture well. So it could be after an exploration well, there isn't the right potential, and that area is not pursued and invested in and developed. But in the UK, as you know, we've had a couple of wells that have targeted shale. The Lancashire well, the Bowland well that was drilled by Quadrilla in 2011 is an exploration well, a vertical well pretty much. And they're, of course, interested in whether the next scale of the operation is going to take place into a sort of development. Now, at this stage, the hydraulic fracturing that's required to get the methane or gas or oil out of the rock, the scale of the operation is quite significant. You need lots of fluid. Between 2 and 16 Olympic swimming pools of water is a general rule of thumb, which may come through a pipeline if you can get municipal water, which I believe is what Quadrilla did in Lancashire, or in the United States, sometimes it's been brought in with trucks. You'll need a lot of fluid. You'll need frac crews with big pumps on the backs of lorries, which pump the fluid underground to sufficient pressure to crack the rock. So at this point, there is a lot of activity, lots of trucks, lots of some noise. There's the pump trucks will make noise. And of course, you've got to take the flowback water, which I've already told you is contaminated to some level with natural contaminants, plus the ones that have been used, that flowback water also has to be removed from the site somehow. When it goes into production, you've actually got quite a small area of land being used, perhaps the size of a cricket pitch, with a wellhead on it, which is perhaps the height of a human. And actually, it's quite difficult to see these things. And there's lots of these things already in the UK, and I doubt many people see them very often. Has anyone here seen a well being drilled in the UK on shore? Okay, there's about 10 hands gone up. Actually seen a well being drilled on shore in the UK. So it's not a very common thing for us to see in the UK. Then on to abandonment. And of course, abandonment has a specific meaning. Abandoning a well doesn't mean leaving it. It does partially, but it means plugging it with cement and cutting it beneath the surface and then reclaiming the land. So it's a particular set of regulatory processes that have to be gone through to abandon a well offshore and onshore in the UK. And for most of the time, of course, a well is going to be abandoned. It's going to go into production for a number of years, and then for most of its life, it's just going to be a borehole that's been abandoned and is still there. We know that shale gas has had a huge impact in the United States. It's caused the price of gas to drop dramatically. It's been quite revolutionary in the United States and is set to increase in the future. And of course, it's caused huge excitement in the UK as well. We use around 2.8 trillion cubic feet of gas per year. About 1.8 of that is imported. And you may well be aware that around 2004, 2005, we went from being a net exporter to a net importer because UK production from the North Sea primarily, of course, has been dropping. So we import 1.8 trillion cubic feet of gas. It's used for all sorts of processes, all sorts of purposes, including domestic use, power generation, and in the chemicals industry. So it's an important energy source and feedstock. The estimates that have been done for how much shale gas and oil are in the UK are quite significant. The estimate for the Carboniferous in northern England was produced by the BGS, the British Geological Survey, and one of the numbers they produced was 1,300 trillion cubic feet, was the P50 number. This is a huge number. 10% of 1,300 trillion cubic feet would be bigger than the entire production from the North Sea to date, which is around 88 trillion cubic feet of gas. So these are giant numbers. But the limiting factor may be how many wells are drilled. In the United States, each well, on average, and I'm talking averages, produces 1 or 2 billion cubic feet. That sounds like a lot, but you would need tens of thousands of wells to produce 10% of just the New England Bowland Shale, because each well produces a modest amount of gas based upon US statistics. So these numbers are huge. How much will be brought to surface is about how much each well produces, the economics of the wells, and also whether the social license to operate that industry talks about is actually there and industry is allowed to drill the wells. The southern part of England is also important, and I understand that there may be some numbers being published soon from the British Geological Survey, who are writing a report on this. And of course, these are well-known oil provinces. Wytch Farm was, in the early 1990s, one of the biggest onshore oil fields in Europe. So these are proven oil provinces, of course, because they're proven oil provinces, they may well also be good for shale gas production or shale oil production. Okay, so we know all of that, I guess. What's happened recently is it's become an incredibly controversial topic. People are very unhappy, some people with a number of issues. And I've tried to summarize them on this page. These are the sorts of things I've heard about recently. People have been worried about earthquakes, water contamination, land contamination, subsidence, even long-term health risks associated with shale gas and oil. And the role of the REFINE project is to dig into each of these topics, and there's many more that I could have put on this page, and find out what do we know about the science. To do so independently, without bias, agnostic, all of the things you'd expect good British scientists to be doing, and that's what we're doing over the next couple of years. There are three questions I wanted to raise in this presentation. Firstly, Josh Fox made a film. Has anyone seen the Gaslands film? Okay, so a handful of people have seen it. Has anyone seen the image of someone lighting a tap? How many people have seen that, the image of someone lighting the tap? Okay, about half the audience. These are evocative images. Can fracking cause contamination of water supplies? That was the first question we tackled in 2012. The second question, prompted, of course, by activity in Lancashire, was can fracking cause earthquakes? And if it does, how many? And those sorts of questions. And thirdly, a question that we've also looked at is leakage from wells an issue? How many wells are in the UK onshore? How many hundreds have been drilled? Who owns them? Are they leaking? What do we know? What percentage? So those are three questions I'm going to deal with in the next sort of 20 minutes. Anyone know what's wrong with this diagram? Sounds like an undergraduate lecture, but it's not meant to sound that way. What's wrong? It's an important point. What's wrong with the diagram? There's no scale. So this has come up at a number of conferences. It's quite embarrassing. By the third day, of course, people are showing their presentation, apologising for the fact there's no scale bar. But we do need to put scale bars on diagrams. This diagram is quite bizarre in a way that it shows that the fracking is taking place just underneath a drinking water aquifer, and there's some big cracks here, etc., etc., etc. But the question is, can fracturing cause water contamination? Are these fractures really tall enough, vertically extensive enough to reach an aquifer? What is the evidence for that, if there is any at all? Well, there is a number of pieces of data that are available. This is a plot for the Barnett Shale published by Fisher and Warpinski, who work for Pinnacle, which is part of Halliburton. And they published all their data on the Barnett Shale, plus a number of other shale provinces in the United States. The vertical scale bar, let's talk about that, is in feet. Down here is 8,000 feet, right up to about 4,000 feet here. And what they simply did was put all of their data for the Barnett Shale of fracture height, measured using the microseismic method. They put it all on one graph. So these spikes are the records of the fractures. These are the fractures. Okay, and there's lots of small spikes, and some of the reservoirs were down at 8,000 feet, and some of the reservoirs were as shallow as 4,000 feet. The blue bits was the depth of the water supplies, the drinking water supplies, the aquifers, potable aquifers up here. And the point they made was there's a huge gap between the tallest fractures, which were up to 600 meters high, where fracking fluid perhaps had intersected a fault, but there's a huge gap between that and the aquifers. What we did at Durham University was a pure statistical piece of research. We took all of the plots, and there were 5 of them, and converted them into probabilities. What's the probability of a fracture going 100 meters, 200 meters, 500 meters, 600 meters? Because someone had said that fracking was causing water contamination. Well, is that likely or is that unlikely? Well, the tallest fracture that's recorded using microseismicity that's been published by Halliburton is around 600 meters high. And on this plot, and this is from thousands of data points, we can actually read off different figures. You know, the chances of a fracture extending 350 meters, around 1%. And of course, as you get to 400 and 500 and 600 meters, it gets to be a fraction of a percent. So there aren't any fractures that we know of from fracking that have gone from 3 kilometers depth to an aquifer. The only place where that may have happened, and even this is controversial, is Pavilion, Wyoming, where they were fracking very close to an aquifer, just beneath it, and they didn't have the 2 or 3 kilometers separation distance. So the research that we've published shows that fractures simply aren't tall enough. In other words, they don't do this. They're all down here. They're not tall enough to make their way up towards the aquifer. There is no hard evidence that fracking, and when I say fracking, I'm not talking about truck traffic, I'm not talking about illegal or sloppy practices at the surface, I'm talking about the process of hydraulically fracturing rock. There's no evidence that hydraulically fracturing rock causes water contamination. Not really any strong evidence that we have come across. And if you know of anything that contradicts that, please do let me know, send me an email. We don't think there's any evidence to support it because fractures aren't tall enough. You can. If you pump for long enough, with enough fluid for many days, you will get a fracture to go from a kilometre to the surface. It's happened accidentally. Statoil, offshore, were pumping wastewater into the Utsira sand, and they pumped too fast into a sand which was lower permeability, couldn't take the fluid as quickly as they thought, and over between 35 and 70 days, they got a fracture to go from 900 metres to the surface, where they formed a crater several times the size of this room. It's on the internet, you can look at it, it's called the Tortoise incident. But it shows that actually layers of rock provide a good series of barriers for fractures, because they provide mechanical contrasts, and also porous permeable rock will take the fracking fluid, take the fluid and take the energy out of the system. So because fracking is taking place over short periods of time with reasonably modest amounts of water, fluid, we're just not getting tall enough fractures to cause contamination. So this image is evocative. It's what people in Ukraine, Bulgaria have seen. They've all seen this, just like a large number of people here have. But it's not caused by fracking. Journalists were talking about people igniting taps in America in the 1970s and 80s, well before this industry had started. And of course, in aquifers, you can get biogenic methane, which is caused by the breakdown of organic matter in anaerobic conditions. And, of course, you can get wells that weren't cemented properly or leak, which can also bring thermogenic methane to the surface. So an important message, does fracking, and when I say fracking, I'm talking about cracking rock underground, I'm not talking about all the rest of it, does it cause contamination of water? It's pretty unlikely, very unlikely. There's really not much evidence to support it at this stage. And if that changes, we'll be the first to publish the paper, I hope. Okay. Earthquakes. Can fracking cause earthquakes? This is the earthquake magnitude scale here, and we know that around the world, every so often, there is an absolutely huge earthquake, which is massively destructive. There's only a handful of those, luckily. And of course, there are millions of much smaller events. Now, fracking generally creates energy, releases energy as you're cracking the rock. That level of energy is usually below 0.5 on this scale. So it's below this dashed black line. It's all down here. But that's not always the case. So the majority of the energy is tiny. It is like me jumping up and down on the spot. It can be measured with equipment, but it's not something we can feel at the surface. But we know that's not the entire story, because in Lancashire in 2011, there was a 2.3 magnitude event and smaller ones, which were reported by people. That's also happened in Canada. A 3.8 event was the biggest in a series that occurred in Canada in around 2011 as well. And there's also been events in the United States. But there's only 3 places around the world where felt earthquakes have occurred due to fracking. When I say fracking, I'm not talking about disposing of wastewater, which is another process. I'm talking about cracking rock underground to get shale gas or oil out of the ground. So there are 3 places where this has happened. And that's because underground, there are natural fault systems, tectonic faults that are sitting there. And the tectonic forces, which are around us all the time underground, are pushing these faults together. And they can get to the point of being critically stressed, sometimes how I feel. But anyway, faults get critically stressed underground, and they're about to move, and they will move one day naturally. If you pump fluid into the fault, or you can push fluid in some way, you can lubricate it. You reduce the effective stress, as the technical terms that people use. You lubricate it, and it shifts, not in 10,000 years' time, but while you're doing the fracking operation, or several hours later. So fracking can cause seismicity. There isn't any debate about that. The question is, how often does that happen? How important is that? And how do you compare it with all the other causes of seismicity? So this is a graph that we put together in 2013 of 198 examples of induced earthquakes, which we've created since 1929. The vertical scale is the number of earthquakes that have been documented, and we only took earthquakes from the published literature. And on the horizontal scale is the size of those events. So you can see the different numbers here, and the colour scale here are different causes. So, for example, oil and gas field depletion, red, the oil and gas industry, by depleting oil fields, have induced some reasonable size earthquakes. Ekofisk. I don't know if anyone's heard of Ekofisk, but Ekofisk is a reservoir that's collapsing quite dramatically, and they have to jack the platform has to be built up every so often to stop waves hitting it because it's subsiding. The subsidence in Ekofisk has generated decent-sized earthquakes. So natural oil and gas field depletion causes earthquakes. Filling dams with water, China, up to 7.9. Massively debated, but it's there in the published literature. Thousands of people have been killed. But filling a dam with water is a known trigger for earthquakes. Other things on here, geothermal energy, wonderfully clean source of energy, geothermal energy. But, you know, Basel, Switzerland, magnitude up to 3.9, I think, if my memory serves me. Now, fracking for gas or oil is the black part of this. There have been 3 places where it's occurred and there's been felt seismicity, a couple down here and 1 between 3 and 4, that was in Canada. So when you put this into the sort of league table, fracking for gas is a very unimportant, at this stage, cause of induced seismicity. Obviously, if you're disposing of your flowback water, remember the water comes back up to the surface and you have to get rid of that or clean it. If you're injecting it, well, wastewater injection, the biggest event, not on this graph, I don't think, is 5.7. So wastewater injection creates bigger events because you're injecting for 5, 10, 15, 20 years. That's an entirely different thing from injecting for 1 to 2 hours per frac stage. So fracking does cause earthquakes. It has happened. People should be very cognizant of it. There will be faults which are critically stressed. They need to be avoided. Industry needs to acquire the right data to avoid the faults and understand which ones are feeling critically stressed and could move. But if we compare it to a number of other processes, it's not particularly significant. And if you were to ban fracking on this basis, you'd have to start with a whole load of other things first. We are doing research on this at Durham, not led by myself, but by a colleague of mine who's taking all the natural earthquakes in the UK. And it's a bit of a mishmash here. This is the BGS's map of the British Geological Survey's map of all the natural earthquakes. But of course, the reason it's a bit of a mishmash is that events are coming from different faults underground and then being recorded. What you really need to do is take all those events and position them correctly in 3 dimensions. So you can say it's this fault that's generated all of those data points. And that would allow you to know which faults are actually creaking underground, they are critically stressed and they should be avoided. So that's some of the work that we're doing in Durham to try and have a better idea of which faults are active in the United Kingdom. Okay, the last part of this talk is about well integrity. When the well is drilled, as I'd already said, the well is drilled with casing, and as the casing is inserted into the well, it's cemented into place, and the integrity of that part of the well is tested before the well is drilled to deeper levels. And those are very common techniques that have been around for a long time. And then when the well has finished being used, the well is filled with cement plugs, and different regulatory authorities will have different regulations on where those cement plugs are put. But so you've got steel casing, and then you've got cement, which is sealing that steel casing in the hole, and cement plugs. But all the regulation in the world won't stop steel from potentially rusting and corroding, or stop cements from cracking. Those things happen, I'm afraid. So we do know, and I think it's generally accepted, that there will be some wells which leak over time. And this is an important issue. So here's a picture of a few wells here. Here's a wellhead. Now, once the well has been finished with, you can see it's got here's the cement, and the casing looks very, very good indeed. Once it's been finished with, it's cut and sealed. And in the UK, that well will be buried so the land can be reused. And we have 2,152 wells in the UK, drilled from 1902 to 2013. So over the last approximately 100 years, 2,152 wells. Most of them are abandoned wells. So they have been cut, they've been cemented, plugged, cemented, and cut, and the land reused. So 65% of the wells in the UK, you can't put your hand on them. You could find them, because there's a map you can get online, but you couldn't actually touch the well because the land's being reused by the farmer or whatever the land use is. So that's what happens to wells. And then around 300 wells, and I haven't got exact numbers, are actively used right now. They're wells that are in active production or being used in some way. Okay, so out of the 2,152, the majority are abandoned, sealed, and buried. Now, if you look at big data sets on well leak, one of the best ones was published in Alberta, Canada. It involved 316,000 wells, over 316,000 wells, drilled over the last 100 years. And they compiled all the data and found that 4.6% had some sort of problem while the well was being monitored, while the well had been drilled, or during its life. Now, in the United States, in Pennsylvania, where the Marcellus Shale has been very productive, there have been several thousands of wells drilled in the last few years, they put this data online. So you can actually look at the database, anyone in this room could do that, and you'd find that about 6% of wells drilled since 2005 up to 2013 have some sort of well infringement related to an internal leak, like perhaps part of the cement has failed, or an external leak. Now, those are two different things. An internal leak is something that has not got into the environment, and is quite, up to 6.3%, and a small percentage of that will be leaks into the environment, including blowouts. Okay? Now, has anyone know of a blowout in the UK onshore? There is one. 1981, there was a blowout, gas blowout near Doncaster, the Hatfield Moors development. So we've had one blowout, a serious well leakage issue that is published, it's documented, that has occurred, but it's a very unusual event. So we do know this is an issue. Either it's a slow process and there's a small percentage of wells that could leak, hence this 4.6 number, or that people don't predict, and we have many of those in history. Sorry, clicker, I'm not doing a good job with the clicker at the moment. And I actually have stopped working. Okay, I've only got a couple of slides left, so even if this fails, it doesn't really matter. So 2,152 wells drilled in the UK so far. There was a peak in drilling activity during the Second World War. Many wells in this period were drilled by a company called Darcy, which was later taken over by Burma Oil, which was later became some part of BP. I'm not sure which part of BP. But a number of wells have been drilled, and we do have wells, up to 53% of wells in the UK were drilled by companies that went bust or were taken over by other companies or merged with other companies. And we're not absolutely sure, and I wish I could tell you different, that what the ownership situation is with up to 53% of wells drilled in the UK. Because a lot of them were drilled in this period, a long time ago, and lots happened since then. So there are a number of wells that we don't know the situation on. For monitored wells, for active wells, a well inspector collects information that's passed to the HSE on whether there's been any issues, but that is not in the public domain as I understand it, as I stand here tonight. I don't think it's in the public domain. And for the abandoned wells, no jurisdiction we know, including the UK jurisdiction, monitors abandoned wells. So, well leak is, I'm afraid, something that will happen in a small number of cases. For people to really understand that, we need to know how important the problem that is. And in the paper we published recently, we simply compiled 25 different studies on well leak. Unfortunately, it was a real potpourri, okay? In other words, this particular database here, this was a very small data set of 50 wells drilled in the Santa Fe Springs oil field in the 1920s. And up to 75% of the wells were leaking. Right through to more recent wells drilled in Pennsylvania, where we're seeing 6% perhaps have got some sort of internal or external leak. Now, we don't know where we are for the UK because the data isn't available. And if I'm wrong about that, please do send me an email. But we don't think there's data on active wells, public domain data. And then monitoring of abandoned wells would be interesting to have because it would show the true cradle-to-grave emissions of drilling activity. Of course, it has to be put in perspective with other industrial processes, petrol stations, and other things. So I'm not saying this is a huge issue. In fact, I doubt many people in the room have reported a well leaking in their vicinity because they've noticed the quality of the water going down. So it's probably a small issue, but people want more than that. They want to know where in here they are. Is there a problem with their local well? In Pennsylvania, that information's online. So just to sum up, I mean, I hope you've been sticking with me with the main principles I've been talking about. I'm looking for nods and shakes. Hope you've been happy with what I've been trying to describe. The key conclusions are this, that fracking, and when I say fracking, I'm not talking about the whole process, I'm talking cracking rock underground, is a very unlikely cause of water contamination. There's really very little data to support that. There are only 3 places where people have reported felt seismicity caused by fracking activity. And there are other processes which create bigger earthquakes than fracking to date. Doesn't mean we should be complacent, that industry should be complacent, or the regulators, but it's not a huge issue up to now. In the UK, there's 2,152 wells. There is some question marks about ownership of some of those wells. And of course, historically, there have been issues that wells drilled a long time ago are potentially leaking now. And we know well leak is an issue, that it could occur. It's important that there's data available to understand the scale of that issue and to reassure us, and also to make sure that we're not creating a legacy, not just for our children, but for our children's children. And lastly, let's all contribute to a better quality debate. These diagrams without scale bars where people are just completely misunderstanding what's going on don't help anyone. We need good research. We need it to be independent. We need it to be neutral. We need to be honest. We need data in the public domain. We need to keep researching these issues in order to fully understand the environmental impact of shale gas and oil, if indeed it goes ahead in the UK. Thank you very much. We'll take the time, yeah.
Well, that was excellent. Richard's rushed through to give time for questions. So we've got our roving reporters with the mics, and we'll start. Where should we start? Oh, gentleman in the white shirt in the middle.
Hi, Martin Wright. Can I ask 2 questions, actually? Firstly, what actually happens to the wastewater? You talked about it sort of containing pollutants from the fracking and natural. What happens to that? And the second question I actually have is to do with the way fracking actually works. You showed the 2 pictures of when you're doing the sort of exploratory drilling and then actually when you go into production. And in production, it's just a little sort of drill sticking out of the ground. So what happens to the water there? Because why does it not need all that water when you're in production that you did need when you were doing the exploratory drilling?
Okay, thank you. So depending on where you are in the world, different things happen to flowback water. In Texas, they have 52,000 injection wells, which they can use to get rid of flowback water and other wastewater that they have. In Pennsylvania, I think they have 8 injection wells because the geology isn't suitable for deep injection. So in the United States, they can inject it or clean it, and in Pennsylvania, they've had to innovate and start cleaning it, cleaning it because they can't inject it. In the UK, you can't legally inject wastewater unless you're supporting an oil field, production from an oil field. So we'll have to have cleaning, as far as I understand, in the UK. Once the productions, after the fracking has happened, you've opened up the well and you've produced a pressure gradient. You've got high pressure underground and less pressure at the surface. And so everything you've just pumped underground will want to come back up the wellbore in a controlled way into tanks and so on. So the water comes up and gas, and that stream cleans up until you've got dominantly gas, and that's the dominant phase and fluid that you're getting to the surface. So once you've done the fracking, you should have a gas stream. You can go back and refrack wells in order to keep that gas stream going. Hope that helps.
Let's go over this side.
There's one down at the front here.
Yes.
How do you get the drill to go at right angles from the perpendicular? You reach the right depth.
Yes, that's a very, very good question. And there's a couple of different techniques. You firstly get someone called a directional driller, who does it for you. That's what I would say as a geologist. So you get a directional driller. But one way you can do it, let me just explain one way, is that the drill, if you like, is bent. It's one way of doing it. It's actually bent, very gently bent. And as it goes down underground, you can rotate it so that the bend is pointing up or pointing down. Are you with me? So if you had a bent piece of steel, you could point it up or turn it round and point it down. That's one way you can do it. There's many ways of doing directional drilling. And the industry's innovated to being able to thread the well. It's fantastic, really, within particular layers of rock. Here we go, right in the front.
Yes, thank you, Michael Fuller. You make it sound very simple.
That's my job.
Water, chemicals, and sand. Are you able to tell us what some of the chemicals are, please?
Okay, that's a good question. So this has been an issue because people have been concerned that there hasn't been full disclosure of the recipe that a particular company uses in their fracking fluids. And Frack Focus in the United States, which is a web page, you can get quite a lot of information there. But generally, and this is not the case for every well, because I think they vary it to get the best fracking operation, depending on the geology, they put things like something called guar into the fluid, which is used in milkshakes as a thickener, which helps give it enough viscosity to take these grains of sand into the cracks. They sometimes use biocide, which stops the water deteriorating either in the tanks at the surface or underground where it's nice and warm. They can use a little bit of hydrochloric acid. You know, when they start, that well is cemented in with cement. Just to clean the well up, you could use a little bit of hydrochloric acid. So they use a number of different chemicals in order to get the best fracking operation, the most optimum fracking operation. There is a push to reduce the reliance on bad chemicals, if you like, greening up the whole process. So they're trying to replace these with better products. I thought, and people can contradict me if you know different, that the UK onshore operators, and there's a group of them, were going to have there's going to be open information on fracking chemicals, and I believe Quadrilla tell you what the fracking chemicals were that they used in their Lancashire borehole. So it doesn't help, does it, when there's these question marks, but so there needs to be open access to that information as well. Is there no one on the right here? No? Right, let's go right at the back then. Thank you.
Hello. What are the timescales involved to actually do the original fracking, and then how long does, on average, I suppose it will be, does each well produce, and how long has it got to produce to be economic?
Yeah, wow. There's three questions which are how long is a piece of string. So I do understand the question. And I can only give you sort of rules of thumb. In the United States, they've got so good at drilling wells. I mean, literally several days to drill a well, which is very unusual, actually. But they're so systematic at it. The fracking may take days or weeks, that sort of thing. And then most of the time, the well will be in production. Initially, there's a very fast production of gas, and that usually declines exponentially. So the first couple of years, there's high production, it tails off. Now, when you actually decide to stop production, may be an economic question. There'll still be some gas, but you think, look, it's not producing enough gas, we're going to stop. But, I mean, I was with Quadrilla talking to them in Parliament on Tuesday last week, and the Quadrilla representatives said, well, perhaps 10 to 15 years. I mean, we just don't know. There's only a small number of wells in the UK, but the key thing is how much gas you get out. And in the United States, the average amount of gas is 1 to 2 billion cubic feet, which is quite modest. Conventional wells often produce more because they're like sponges and they produce more gas naturally. Right at the back, let's stay at the back. The one in the blue shirt.
Is there the potential for these wells to start producing sour gas?
So sour gas, H2S, you would know, I think, early on whether you had sour gas in the well. And they may need to put some butane and propane in, some heavy hydrocarbons, no sour gas. So if you've got sour gas, you'd know about it early on, and you may have to engineer in order to deal with it, just to clean it.
But the wells, if they're long-lasting wells, could they become infected further down and then produce a sour gas?
If you drilled a shale that has got sour gas in it, you would know about that, and so corrosion would be something you would know about. You can, I mean, I'm not an expert on this, but the metallurgy of the steel can be modified depending on what sort of fluids you're producing, the steel that you use.
Thanks.
Ah, from the right. Or my right, anyway, your left.
Has any assessment been made of the amount of shale gas that is available offshore?
That is a very good question. And the quick answer is I don't know of an assessment, but it's not the first time that question's come up. I spoke to one major operator who said, I mean, one of the issues of offshore platforms is they don't have enough energy to actually power the platform. The turbines on the platform, which keep the whole thing going, bizarrely, there isn't necessarily enough gas. So one company said, well, perhaps we should do some fracking in a shale near the platform in order to at least power the platform. Now, the economics offshore are going to be completely different. There is a license offshore Lancashire that was awarded recently for shale gas, but the economics are different. The rates of flow and the number of wells you need the number of wells you'll need is high, and so the economics look difficult.
But you've already got an infrastructure out there.
You have an infrastructure out there, and perhaps a soft landing, if industry goes ahead, is at least use the gas to power the platform as a start-off.
Right, we're going right over there.
Hi. I really like your last point about better communication. I think is very significant. I just wondered if you could expand a little bit on how the Refine project is engaging and communicating with wider audiences, particularly policymakers. I know you've mentioned the Parliament.
That's a very good question. Well, the first thing we're doing is we're publishing peer-reviewed papers. We're then translating the peer-reviewed papers into 2-page briefs, which are written not by me, but a colleague in a language that most people understand. And then we translate those into 13 languages, including Mandarin and all the Eastern European languages, so that everyone has access to the data. I think half of our activity is, one of our 9 projects that we're doing is a social science project, looking at focus groups in the United Kingdom and in Eastern Europe. We've also had, I've supervised or co-supervised a social scientist who's done focus groups with 6 different groups in the UK, allotment owners, women with young children, business leaders, ex-miners, to try and work out what it is about fracking that worries them. And of course, the word energy is a politically charged term. There's a whole series of reasons people are worried about fracking, not necessarily anything to do with the science. So, and then we talk, of course, regularly to industry, as you'd expect us to NGOs, to resident groups. We've got to the Residents Action Fracking Filed, involved in a little student project we've got going. We talk to the House of Lords. I mean, I've given evidence in both houses. We do all of those things. So you'll rarely hear us say no to coming to give a talk. Thank you for the question.
Lady in the front here. Keep on coming down. Down, down, turn left.
You mentioned the fact that there's no information about dead wells, and the fact that in the older ones you wouldn't even really know who still owns them. Once the land's sort of been returned to the farmer, is there anything to stop you going to just sample a few of them? Is it just a question of sort of finding obviously the funds and the organisation, or is there also a legal obstacle?
Well, we're just about to find out, because we're going to look for 50 wells, and we did a survey of 4 wells in the northeast of England. We just picked some that were nearby and we went out to look for them. 3 of them were underneath farmland and 1 was in a housing estate which was being built on. And so those 3 wells, we got access, all 4 of them we got access to. We were allowed to get on site and to do some measurements. So basically the ownership of the well, I'm not absolutely clear, and it's a legal question who owns it, but it may be the landowner owns the well, and it may not be, and it depends on the licensing and the regulations and what the regulations were at the time the well was drilled. It's complicated, and so I think there needs to be a thorough piece of research, probably done by a legal firm, to go through the 2,152 and clarify But I think, on the whole, people, some people say, yeah, come on, I believe there's a well there, have a look. But that's a case-by-case basis, and we'll find out soon.
Suddenly, in the front. Let's go.
What's the overall efficiency of fracking? Now, presumably there's a range, and it must depend on how good the frackers are. So the concern is, are you getting 10% or are you up nearer the 60, 70% efficiency?
When you say efficiency, you mean
total recovery of gas that's possible?
That is a very good question, and I don't know I don't know if anyone can help me, but there's some industry have something called a recovery factor, and in a normal oil or gas field, you may get 40 or 50% of the oil or gas out, depending on the complexity. Now, I don't know what it is for shale gas. I don't know if anyone can help per acre or whatever. All I do know is that the average total production, in the US is somewhere between 1 BCF and 5.9 BCF, and the average is around 2. That's the killer number for me, because it means you'd need thousands. I mean, we import 1,800 BCF a year. So if each well is only producing 2, you need a lot of wells to wean yourself off imports if that's your target. I don't know what the targets are, but if it was. So I think when people say how much gas is there's a common question. I say how many wells are going to be drilled? And that's an economic question, it's a social question. So I can't answer, we don't know.
I really did mean the efficiency of a reservoir. What percentage can you get out from the total reservoir?
Yeah, and I don't know the answer, I'm afraid. Unless anyone else does, any industry people who can help me on that one? No one's volunteering.
We're coming up to the hour, so we've got time for one more. Gentlemen down the aisle there. There we are. Why don't we go there?
Okay, thank you. It's going back to the question on communication. And it's the idea that there's a lot of publicity at the moment about shale gas, and not all of the complaints are necessarily relevant to actual what fracking does. So the question is, kind of whose responsibility is it to communicate to the public? Is it academics like yourself who can study it? Is it BGS or the Geological talks like this? Is it the industry, or is it government that should be talking about energy policy and then the science and the risks of doing this?
Okay, so you've got me on I'm not someone who can answer that question, but I'm going to give a little bit of an answer because I don't work on whose responsibility it is. But let me just say what I see, and other people can chip in with what they see as well. Firstly, there is DEC, Department of Energy and Climate Change, there's the Environment Agency, there's HSE as well. There are organisations called, I think it's called ScienceWise. Is it called ScienceWise? There's an organisation that is there to try and communicate science more effectively. Professional societies, Geological Society, we're here communicating science right now. Academics, informed members of the public. I mean, it's everyone's job, as far as I can tell, to start talking about this and tell people about it, and to do it in a clearer, slightly less charged way if they possibly can. Because we don't want to look back in 20 years' time and say, do you know what? We were actually not looking at the key issues. We were so flummoxed by this and that and the other. There were key issues we didn't tackle. We didn't push for well monitoring when we could have, because that was the issue and not the fracking itself. So lots of people. I think academics have a critical role. A straw poll was done in Pennsylvania of academics to see who was the most trusted people. Was it the regulators? Was it industry? I'm pleased to tell you that it's still academia, that we're still trying desperately, usually with finite resources, to get research out and to do it independently, because our careers are built on being independent and the universities we work in are built on being independent, and we have to keep doing that. So I think academics have a great role. And academics perhaps have come to the question quite slowly. It sort of dawned on us, oh wow, there's an issue that needs solving. And of course the research machine takes time, and it's iterative, and we make progress over long periods of time. So there's no magic bullet on the communications, but let's do it a bit better in the future.
Well, thank you. Thank you, Richard, for an excellent hour.
Thanks, David.
Richard has to make